So I said this afternoon I'll be talking about what is artificial intelligence. And I know we've been hearing what is AI, what is AI. So we'll be defining some facts and some myths about AI today. Also, we'll be talking about what is machine learning. All right, so let's kickstart this morning. Okay, when you look at the word artificial intelligence, you find out that artificial intelligence is a field of study that embodies other studies, or what I call it of other fields, such as machine learning, deep learning, and generative AI. And it cuts across even more than generative AI at the moment. We also talk about agentic AI. It's just like a field of study that covers everything that you need to know. Machine learning is a branch of that AI that focuses on what creating intelligent machines or intelligent systems that learn from data. And when you talk about deep learning, it's just a subset of machine learning, but now based on what artificial neural networks. So we are trying to mimic the human neuron, now converting that into a machine system, creating a kind of neural path for the machine system to be able to take in information, learn from that data set, and give you what your desired results. Then you have generative AI, and you talk of the likes of ChatGPT, your GANs, your LLM, and your large language models, your generative adversarial neural networks, and the like. So when you talk of artificial intelligence, it's just a kind of body, a field of study. It embodies. Put artificial intelligence, I say artificial intelligence is the brain. It's the brain of all these other factors that you find like machine learning, deep learning, and generative AI. So without artificial intelligence, they can't function just with the way our brain is. When your brain is not there, the brain is being tampered with. You find out that there's a problem with your psychomotor. With the brain, the brain tells when the arm needs to move. Your cognitive, the way you think, then your affective, which has to do with what your play or how you react to other things. So that's just the way artificial intelligence is. More than that, what is generative AI itself? The generative AI refers to a system that can generate content based on data they've been trained on. Like I tell people when I'm opportune to take classes like this or have facilitate courses like this, I say what? Data is the oil for what? For AI to function. I'm sure you've been hearing a lot of things saying data is the new oil, data is the new oil. And that's the same thing that happens when it comes to AI. Without data, AI cannot function the way it should function because it has to learn. It's just like you learning from experiences. How do you know that when I put my hand into when a candlestick is being lit and I put my hand on it, how do I know that it will burn me or it will hurt me? Because I've learned from what, and that's the same thing we do. We feed it with data that has been well thought, well processed. Then it learns patterns from that data. Then it begins to give you what your desired outcome. All right. So let's understand the generative AI more. As it's a subset of artificial intelligence that focuses on what? Creating new concepts, such as text, images, audio, code, based on learned patterns from what existing data. Just like I said, you can't function without what? Without data. Very, very important for us for your AI to function without receiving data. So it's just like you fueling your car, and without you fueling your car, maybe your gauge is at the lowest. It won't take you to where you want to go to. But when the gauge is at the fullest, then you can move around and plan your day. Just the same way data as well is the car. I would say data is what is you AI. Then these are models are what they use complex neural networks to understand patterns in data and produce what human-like output. Like I said earlier, just like the way your eyes see, how do you know when you see me that this is Oluwole talking to you? Or how do you know the color or the color of the excess I'm putting on? It's because you've seen that the message has been passed into your neuron through the optical nerve through your neuron, and it sends it to your brain to tell you, okay, what am I looking at? The same way scientists have come together to sit down to mimic what the way the eye receives information. I think you begin to hear things like computer vision and then the like. So using what complex neural network. So now layers of mimicking the human neuron and also be developed using some statistical and mathematical formulas also to build models that can take in data sets, learn patterns from that data set. And that's why you find out that if I feed ChatGPT now with two pictures, a picture of a dog and a picture of a cat, and I say, what is this? Because it has learned from data that we fed with it. It will tell you the first picture is a cat, the other picture is what? It's a dog, because it has learned from patterns. What is the shape of the ear of the dog? It's different from that of the cat. The whisker, what is the number of the whisker at the cheek of the dog and the cat? And what are the paws? Look at the paws of the cat. What's the difference between that and that of what? And that of a dog. So these are models that use what? So they think just the way the human brain thinks, that's the same way also they mimic what? To think and learn in patterns. Then you have examples that include what your ChatGPT. So we are also conversant with ChatGPT. Because if you are not careful, the misuse of ChatGPT at the moment now is so scary. I tell people everything, even somebody wants to write a simple, message to a friend, you need to consult ChatGPT. You can see the power of generative AI. You can ask ChatGPT a question. If I do this and do that, what will the outcome be? I will ask ChatGPT if I read for about 2 hours and play for about 5 hours, what will my result look like? So it will just give you a preemptive conclusion to say, okay, if you have to work at this rate and you play at this rate, using some calculations, okay, if you want to get at least this scores or things like that. Then you have your DAL E and your DAN. These are examples of our generative AI. All right. Then there are some myths and I call them misconceptions about generative AI. Someone once said, he says AI has come to take our jobs. How true is that? When you ask yourself the question, how true is that? The AI has come to what? To take what? To take away our jobs. The next thing that should come to your mind is how true is that? Has AI truly come to take our jobs, or what is going on? And I remember one of my professors, Professor Anna, who said to me when I was studying under her and she was teaching me generative AI. He said AI has not come to replace human jobs. AI has come to what? To replace those who refuse to embrace the use of artificial intelligence. You can see that now. Because the world is like a global village, and trends, a lot of trends begin to change. Things change every day. Every day you wake up, you find new trends. So we must embrace this trend. So that is it. And the first question I ask, are these sentient? Are these sentient? Is AI, generative AI, is it capable of sensing and having feelings? Do they have feelings? Are they sentient? Are they capable of feeling? Are they conscious? Are they aware? Someone once said, he said, the moment we teach machines to feel is the moment we ask ourselves what it means to be human. Ask yourself, can a machine actually get to that stage that it can work? It can depict or detect emotion. I was in a philosophy and an ethics group in Mauritius. That was 2024. And we were having an ethics meeting, and somebody said, an AI that mimics emotion is not sentient. That it is a mirror reflecting our humanity back at us, not a soul looking out. Yes, it mirrors, like I said, without data, AI cannot perform. So whatever you see and it looks as if the AI tool or the AI system is performing so fantastic, it is because somebody has been able to give it data that can make it to learn to, up to a reasonable point that it feels as if AI can mimic emotion. No, AI does not mimic emotion. They use patterns based on the data that has been fed. If you look at my left hand side here, also there are some myths that says what? Only big tech companies need what? No, not for tech companies alone. It's accessible to businesses of any size, even to you. Everybody use ChatGPT unless when you want to go further, then you are being told to pay for premium. But for the basic, you have some basic views that you can use there. Your chat GPT. Does it create anything without limitations? No. Like I said, it is data dependent. Drives what? Data dependency drives what? It's performance. It is just garbage in, garbage out. It is whatever you feed, it gives back to you. So how well you feed the machine, that is the kind of what the response it will actually work, it will actually throw back at you. So that's just it. All right. Then openly I said, it said ChatGPT does not have what awareness or emotion. It predicts the next word based on what? Based on patterns. That's what I've been saying. It can't reason. It's not aware of anything. All it has done is that what? A lot of data has been set in. It has been learning from, okay, anytime I see this kind of image or anytime I see this kind of pattern or feature or structure, oh, this should connote to this. Then it begins to what? Do like a what, an iteration to check, okay, does this mean this, that, then it gives you what? It gives you what? The desired, what's it called? Answer. Somebody once said to me, say, how come you probe ChatGPT so well and it gives you? She said, I don't know how to do that. I tried so much a lot of times and it doesn't work out for me. And I said, it's just the way you prompt. There's a way you prompt ChatGPT, you want to get what you need, and it doesn't hallucinate. It gives you the actual thing, the actual outcome that work for me. So there are no emotions, they are not aware. They only present to us based on patterns that have been fed into them. What are the benefits of generative AI or AI itself? One of the first benefits is what the issue of scalability. You can what you can begin to automate what tasks in sections that before you know it, your day-to-day activities, it comes to a very last scale without you even having to do a lot of things. So there's scalability, there's automation and efficiency. You can automate what repetitive tasks. A lot of repetitive tasks that are happen in businesses, you can just automate those tasks. Just like you maybe having to send emails to your clients and you have to write, you have about 1,000 or there about 100 clients. You can write about clients something so wonderful and people look at it and like they are just like, wow, this is wonderful. This is wonderful. How come you have these skills on? Just because of AI, you can do such wonderful things. They look at the issue of data analysis and insight. You find out that our data analysis we use wonderful AI tools. And you see beautiful dashboards and then a lot of insight has been done. Then you can personalize. You can put your idea, prompt your idea, and AI creates it for you, and you are like, wow, this is actually what I'm thinking about. And there's the issue of what cost effectiveness, you save cost. Then natural language understanding can talk to from the AI to say, my name is this, can you please write a few bio about me? And it's like you're having both a response and what? A call and response, call and response, call and response. So a lot of benefits of what? Of generative AI. Now, this moves us to what is machine learning. Like I actually said from the beginning, AI is what? It's like a covering. It's like a shield over what? Over this other system. So machine learning is a branch of artificial intelligence that allows computers to learn from data and make decisions or predictions without being explicitly what programmed for a specific task. So all you need to do is what feed in the data, point the system or the machine or the model to those very, very intrinsic features that you want it to work or patterns that you want it to learn. Train over time. Then when you train, you test. Then after testing, you can get other external data sets to validate to be sure that okay, anytime my model or the system receives a data that it has not been trained on, it can work effectively and efficiently pick those data sets and actually make predictions and decisions. And that's where the word generalizability comes in. Anytime you hear those of us that are data scientists or machine learning experts talking about generalizability, they're talking about that your model is not just an expert on the data that it has been trained on, but if an external data comes in and it performs perfectly well, then it means that it has generalized well across all platforms. I bring the data from Kenya, Uganda, Chicago, US, Sheffield, UK, and the system still works perfectly well. Then you are good to go. I said, in simpler terms, instead of telling a computer exactly what to do step by step, you give it a lot of examples, which is the data, and it figures out patterns and rules on its own. Then you start talking of the likes of types of machine learning. You're talking about supervised and the unsupervised learning. You can see from the problem here, you can see from the right hand side. What's the problem? Labeled data when you talk about supervised. Yes, data is labeled. It has been pointed. There's a kind of signal to work with. This is what I want you to look for. And you can see the categories. talk about what is it a category or quantity. When you are working on category, you are talking of classification models. You have your neural network, your logistic regression models, your random forest models, your maze bias models, and maze-based models. Machine. It comes to about quantity, you're trying to do a regression analysis. Talk about your SVM also, your neural network, your regression, your random forest or your lasso model. Then when you come to the right hand side where you have unsupervised, it means that nothing is pointing. You are feeding with data and you are telling the system, your model or your machine what. Come on, try and figure it out yourself. Group. So you talk about grouping or what, or lower dimension. When you talk about grouping, you're talking of things like clustering. Then you have these models, you have your K-means clustering model, the Gaussian mixture, you have your BB tetractile clustering, your hierarchical clustering. Then when you talk about dimensionality reduction, you're talking about things like your PCA, your LDA, your I2 map, or auto encoder. So you find out that we are talking about dimension. What are we looking at when you talk about dimensionality reduction? You have your data and their kind of outliers, you know. Data is not actually what well represented, and some of the data are not what following the grade line the way you want them to go. So machine learning is against what supervised learning and unsupervised. When we think of label, supervised, no label is what unsupervised. Alright, so look at supervised learning. Supervised learning is where the model is trained on a labeled data set. You can see they are labeled. So you have the labeled data here. You can see you have a picture of animals. They will label the cow, the elephant, or the camel. So you push it into the algorithm. The algorithm begins to sort out. So when you push it into the algorithm, it treats it and sends it into the processing layer. So when it picks it, becomes a label and the assigned that this is an elephant. So what it does is what? It creates an output that groups elephant into a folder, the camel into a folder, then the cow into a folder. So when you look at my example, I said data, pictures of animals labeled as cat or dog, or just the way we have the cow, the elephant here. So the model learns to classify new pictures as either a cat or a dog, or as either what, or between what, the cow, the elephant, and the camel. How does it work? You get your input, you put it into the model, it predicts what your output. Then you can compare with your actual output. Then you can adjust the model to minimize errors using what techniques like gradient and descent. Because the model, the model is trained using what labeled data and the process to predict outcomes and classify accurately. From this, you already know the output you are looking for, but you want to be sure that my model also fits that. You already know that, okay, I have about what? How many elephants to count here? 1, 2, 3, 4, 5, 6, 7, 8. If I want that to do that, and the model pick that up and also classify and give me that desired output. Alright, so look at it. Where are those places where you can use them to provide learning? Image file detection. Yes, one of those places. You know that what all you do is what you feed the data. What kind of messages do you have? We are talking about email. We are talking about email spam, things like that. We have messages like, congratulations, you just won about $10 million or something like that. Then we use that for also disease diagnosis, which is one of my area. I work on chest X-rays for pneumonia detection. I also work on sickle cell anemia severity classification. So you can classify, okay, where's the upper region, Yes, pneumonia, is it in the upper or the middle or the lower region? So supervised learning does that because you need supervised learning. I was talking about use cases. That's the email spam detection. So when you talk about email spam detection, how do you know when an image is a real image and which images are spam? You find messages like we're talking about hello, you just won about $10 million. Please click on this link. So you feed the model, label those kind of messages that look fictitious, you label them, you give it also normal email and messages. So the system is able to differentiate between which is what, which is a spam message and which is what is an original email messages. Then you look at this diagnosis. Like I was saying, this is one of my area where I work on sickle cell anemia and pneumonia. I use chest X-ray, to try to know, okay, is this a pneumonia, is this a non-pneumonia chest X-ray, or is this a pneumonia chest X-ray? Then we can also go further to probe what region is the pneumonia. Is it in the upper region? In the lower region, or is it in the middle region? This is based on what modeling and labeling, because you have labeled, your system can be able to what to differentiate. Your model can pick up and say, okay, I found pneumonia, and then okay, it is in the upper region. Just like your self-driving car also, same thing applies to that. Then we go to unsupervised learning. It is used when your data has no label. There's no label at all. So you just try to find patterns or structure. So just forget that this looks as if it's label. It's not label. You know that what this is a cat job, but the system does not know. So what you want now is that the system should discover the structure. So this is where clustering comes in. Cluster association. And it looks for similar what? Similar images or similar patterns. And what put them and separate them. So that's what it does. It looks at look at the year. This is different. So this year looks like this year. Oh, this is good. The head, the shape of the head has the same shape. So let me put them together. Oh, this looks flappy. Okay, this looks flappy. It should be together. So you now decide the name and the output, the name you want to give to it. So I say data like a customer purchase data. Then your task is to group similar customers based on their buying behavior. You want to know high class buyers, middle class buyers, and lower class buyers. So these are things that unsupervised learning. So you give the system the model those data sets. They are not labeled. So each thing on its own. Input to discover structure, look at patterns, and cluster them. Okay, all these look alike. Just let me use an example of red, yellow. I have yellow balls, red balls, and green balls. So it looks at it. Oh, all these look alike. I put them in the folder. All these look alike. So that's where the issue of the word clustering comes from. So look at the unsupervised learning use case. That's a customer segmentation, just like targeted ads on Instagram. Have you ever gone to Instagram or you try checking on maybe a funny video and just realize that every time you load your Instagram, it brings out those kind of funny videos that you like watching. But for those of us that maybe you just really fell in love and you've gone to the pages wherever you're trying to get some text and some images to send to your girlfriend or your boyfriend, you just realize that every time you come to you get on Instagram and get to your Facebook page, it takes you directly to just targeting and customer behavior. It looks at it. You see things like cookies and you say cookies. Gathering information of what pattern, the things that you do, what pages do you visit all the time, to then it begin to suggest to you and begin to give you that. Then you can also see grouping images by faces, just like seen in a phone gallery. You realize that your phone gallery just arrange your based on what you can do that and arrange based on the faces. Arrange them, then you can now name those folders. Okay? Then you can find that what AI is all around us. AI is all around us. When it comes to the issue of what behavioral tracking, AI loves everything. And why most of the time, some of us you just accept cookies, you just click on it. And I was talking to someone one day and it was like, well, why didn't you accept that? I said, most of the time you don't know that you are being tracked. AI is tracking, it's monitoring your behavior. The AI loves everything you do. The kind of movie you like to watch, your rating, what you search. But when you pause also, then it creates a detailed profile for your unique case. So for those of us that have Netflix or Showmax guide, you find out that you see that it recommends a lot of movies because based on your patterns have track your behavior on those apps. So you have what you call the collaborative filtering. It recommends movies and shows based on your preferences or preferences of other users who watch similar things as you do. Yes, it does that too. After behavioral tracking, it looks at something somebody is watching also that you also do. So then it begins to work. It begins to recommend to you, somebody loves you, you also love that. Then you have content matching. So the system uses deep learning. Yes, this is more of a neural network. To match specific attributes like a genre or an actor or a scene or the content you enjoy on scene titles. Yes. You just look at it. Oh, you like watching let me look at maybe one of these Idris Elba. You love watching movies from Idris Elba. You just find out that every time you come up on Netflix, you continue to bring what any movie Idris Elba has featured in because it has done content matching. Then look at Google Maps. When we talk of Google Maps, prediction LM models analyze historical and real-time data, including anonymous user feed to predict future traffic congestion on every road segment. It's so wonderful. You can check your map now. I'm going to Lagos now where I stay in Ogun State. I want to leave there. I check my Google Map. How many minutes will it take me to leave from Ogun to Benga? I want to know, is there a traffic grid? What is going on? How do or is there a shortcut I can use to just see traffic and things like that? So we have the issue of optimization. We have algorithm that uses these predictions to dynamically assign a travel cost. Just like your Uber app, your InDrive. You can see that you have travel cost, time cost to each road, calculating the fastest route towards the conditions. And you have correction also. AI can continuously process satellite and street view imagery to ensure the underlying map, speed limits, and road layouts are accurate for yes. You find out that you use your map today, all of a sudden you find out the next time you open, it's telling you it's updated. Because maybe a new feature has been added, the building has just been completed and it has been mapped and has been added. So you see, there's a lot of things going on. It's just around us. Everything we do, AI is there. Look at this content for content creation. Your TikTok, you can see this content understanding. AI uses what? Computer vision. I told you when I was talking about the neural network computer vision. Mimic the way the eye sees takes information and sends it to the brain the same way that your natural language processing, which is the NLP for audio and text, To understand what a video contains, is it a dancing dog in a park? Just imagine the content understanding. Then the For You page engine, it personalizes your page. If you using AI model, monitors what you watch time to time. You like, your shares and comments. Just like your Netflix, especially for those of us on TikTok. It recommends anytime you log on, just deliver for the exact content you are most likely to watch next. You have the rapid feedback loop. This algorithm learns what and adjust your recommendations immediately based on your most recent interaction. So you find out that if you are not careful, you see people are so glued to social media, and somebody told me that I just pick up my phone and said, let me just set a bit of things. And before I know it, I've spent about 2 to 3 hours. It's just because of this functionality that AI has embedded, because it gives you directly, you don't get bored. It keeps recommending, it's like it's interacting with you. Even when it's not saying anything, it's just moving you from one page to the other. Oh, I love this, I love that, and before you know it, you buy the way. Hi. Alright, so what are some popular apps with AI and machine learning algorithms? You can see them here. You can see our Zoom, your YouTube, your WhatsApp, your Twitter, your Google, your Instagram, your Spotify, your TikTok, and Gmail, Drive, Facebook. In lots, to work with these machine learning algorithms. In fact, without this machine learning algorithm, most of these apps that they phase out, because now they use what we call a predictive recommendation. They look at follow your patterns, they learn patterns, user pattern and learning. That's what most of these things do. Oh, what do you like watching most? What kind of content do you like reading? What kind of videos do you like seeing and things like that? You notice on Spotify, and you see that you listen to a lot of music, you begin to recommend, oh, this is the kind of genre of music that you like. Oh, you like hip hop, you keep on recommending even to the latest hip hop or the latest release of hip hop music. So that's one of the wonderful things about AI and the machine learning and algorithm. So as I begin to round up, say here, the future are to build. There's a lot of opportunity for us when it comes to AI and machine learning. It comes across all platforms. Are you talking about health? Are you talking about agriculture? Are you talking about finance? Are you talking about security? Whatever domain you are, you find out that there's an AI tool, there's an AI system that serves you best. And now it's just for us to actually sit down and look at it. What best fits what I do? What do I need? I'm sure somebody will be asking, oh, you talked about the advantages, the benefits and things. Yes, there are disadvantages, but I believe as scientists and people who are ready to change the world, I call us world changers. We should focus more on the positive area. Yes, there's nothing that is good that doesn't have its disadvantage. But if the advantages outweigh the advantages, before you know, we need to face out all these disadvantages. We're keeping ethical measures, a lot of documentations are put in. You're creating your model and your system or your model. You're putting some disclaimers here. You're putting some documentation to say if you use this where you are liable to, a lot of litigation is going on. And that's one thing I think next time when we have the opportunity again, we need to talk about ethics of AI. So I leave you with this few thoughts. And the first thing I think, the last thing I'll say is that, like I said earlier on, AI has not come to work, just like my professor will say, AI has not come to take our jobs, that only come to work to take the jobs of those that refuse to work to absorb the use of AI. So thank you for listening.